Welcome to the 44th lecture of digital electronics. So here we have completed first module and half of second module, including K-maths, Boolean laws, etc. So in this lecture we will be dealing with the starting of second half of module 2, that is introduction to combinational circuits. So what is basically a combinational circuit? What is basically a combinational circuit? That is a question. See, basically in digital electronics or digital circuits, circuits are divided into two. One is combinational circuits and the second one is sequential circuits. Now, combinational circuits are the type of circuits in which the output is generated depending on the present input. Whatever is the present input, depending on the function, or what you can say is depending on the digital function of the logic circuit, corresponding outputs which is active high or which is high or low, is formed. Now if you are going to the general block diagram of a combinational circuit, can have n number of inputs. So this is the combinational circuit. Can have n number of inputs. N inputs. N number of inputs means there are 2 raised to n combinations of inputs. And you can have m outputs. M number of outputs. So here what you can write is m is, or m1, m2, etc. is you can write it as a function of n. That function 2 is in a digital format or digital function. Or digital Boolean function, or we can write it as a Boolean function. For example, if there are 3 inputs, the possible combinations are 2 raised to 3. You have 8 possible combinations. If there are 4 inputs, 2 raised to 4, 16 input combinations are possible. So that is an introduction to this combinational circuits. Now the only factor by which a combinational circuit works is whatever is the present input, it gives the output. And when the input changes, the output also changes automatically. So that is the basic format of a combinational circuit. Now to design a combinational circuit, you need to have the following steps. First one, problem is stated, or you have the problem statement. Should have the problem statement with you. That means what function needs to be executed. Second one, how many number of inputs, and how many number of outputs. That needs to be formulated. Step 3, you should assign symbols for inputs and outputs. Assign symbols for inputs and outputs. Fourth step, form the truth table. From the truth table or K-map, whatever it is. From the K-map or truth table, that is representing the Boolean function. Okay. So this problem statement is again a Boolean function. Okay. Fifth step, simplify the Boolean function if required. Simplify the Boolean function if required. And last step is draw the logic diagram. Based on, you can use AND or invert logic, NAND logic, or NOR logic. So you can go with any of these three methods. Okay. So this lecture was an introduction to combination circuit. So what is a combination circuit? Combination circuit means it works on the present input. Okay. Whatever is the present input, depending on the Boolean function which is given by the circuit, the corresponding outputs are produced. Then another important factor is that the combination circuits can have more than one inputs. That means it can have n inputs and m number of outputs. Okay. If there are n inputs, it can have 2 raised to n combinations. That is, if there are 3 inputs, then it can have 8 combinations of inputs. If there are 4 inputs, you can have 2 to the power 4. If you have 5 inputs, then 32 combinations are possible. Now, if there are m outputs, each output is a function of the input. Okay, each output is a function of the input. Again, that function is also in Boolean format or Boolean expression format. Now, if you are given a problem statement or a Boolean function, how to generate a circuit? Okay, you will be just given with the Boolean function. So you fix the number of inputs and outputs, then designate whatever is the inputs and outputs, then minimize the expression using K-map or truth table, then draw the logic diagram using AND or invert logic, NAND logic, or NOR logic. So this is the procedure which needs to be followed while designing a combinational circuit. Thank you.